Good morning, Year 10s. Today I would like to have a look with you at Venn diagrams, and I want you to be able to understand how to use Venn diagrams to represent relationships between different sets of data. Now, different sets of data refers to different events. So in my video here, I'm using the event of a person driving a Toyota, that's my event A, and a person driving a Holden, that's my event B. And I want to represent different scenarios of relationships using Venn diagrams. What's a Venn diagram? Basically speaking, you're having a box, a rectangular box with two circles in the middle. Now, here's my rectangular box, and I will have one circle for event A and another circle for event B. That's A, that's B. So that means when I do my example later, I'll write how many people are driving a Toyota in the circle A and how many people are driving a Holden in the circle B. Now, if I want to know how many people are driving a Toyota or a Holden, what that means is I really want to have all the people here in the circle. So A or B, that's what I say, but what I would write is A and something that looks like a U and a B. So this U here, or that's something that looks like a U, stands for union. Well, and that just refers to me wanting to know how many people have both, or how many people have either a Toyota or a Holden. Now, the next case is I want to investigate how many people exactly have both. So, A and B. So when I draw my circles now, I want to know those people that have both. Well, see how those circles overlap, and the people that have both cars or both driving cars of both makes are exactly those people here in the overlap. So, and A and B, which refers to both events, would be formally written as an A, and that something that looks like a mirrored U, B. That stands for the intersection. Now, there's another thing I'd like to consider, and that other thing is mutually exclusive events. Well, of course, if you do a survey and investigate how many people have either a Holden or a Toyota, there could be the case that you have people that have either Toyota or Holden, but none of those people has both. That's then what I call mutually exclusive. So that means, in that case, both events would have nothing in common. Another thing we need to be aware of is what a complement is. And I've drawn that up here for you already. If you have a look at the A, there's just one circle this time, and that one circle stands for an event. So then everyone that fulfills the event, or every number that belongs to the event, would go into the circle. But that means everything that's not my event A would be on the outside. So the complement of an event is just the opposite, means not that event. That's what you would say. And when you would write that, you would give that the event letter, so in this case A, with a little dash on top. That's the set notation. Now, I've invented an example here where I have where I've surveyed 20 people, and I've investigated already the probabilities here. So I've said, oh well, that's 2 people that have both, and 8 people driving Toyota, and 6 are Holden, and 8 something else. So how would you write that in a Venn diagram? There's two people that have both. Well, obviously, those two people that have both, they go into the intersection. So they are here in the middle. That's the intersection. That's both of those people. Now, there's a total of 8 people that have a Toyota. But you see there's 2 people in the middle, so they already count. That means on the outside of that circle, on the outside of that, intersection within that circle, there's only 6 people left. So that means you have, if you've given the information that there's 8 people having a Toyota and 2 in the intersection, you have to subtract 2 from 8 to give 6. So 6 people here are on the outside of that intersection, and those 6 plus those 2 in the middle will give you that 8 that have a Toyota. Now, the other information is that 6 people are driving a Holden. So, but 2 are already there in the middle in the intersection, and that means on the outside of the intersection, in the circle for B, goes a 4, because 4 plus 2 will give you the 6. The other information I have is that there's 8 people that have neither a Toyota nor a Holden, and those people are on the outside of my circles. So there we go. On the outside is an 8. Now, this Venn diagram represents the information quite nicely, and it helps us to analyze the probabilities. As there's a total of 20 people that I surveyed, and I want to know what's the probability of the event A, so having a Toyota, and I've got 6 here and 2 there, so that would just mean that's 8 over 20. Now have a look at the complement of this. That means not a Toyota. So there's 4 people here in the circle of B that do have a Holden, but not a Toyota, because those people who do have a Toyota, they are in the middle. And the people on the outside, they have neither a Toyota nor a Holden. So that means if you want to investigate the event of not having a Toyota, so not A, that would give you 8 plus 4, so 12. 12 out of a total of 20. But what you see here now is that that's the same as 1 minus 8 over 20. And 8 over 20, well, that's the probability of A. So what we note down here is that when we deal with probabilities and complements, the probability of a complement of an event is 1 minus the probability of the event. Well, why is that? Well, an event and its complement just means everything. And in probability, that should be the complement. In probability, everything just means 100%, and that's represented by our 1. Okay, so just by the way. Now, what's the probability of my event B? My event B is having Holden, and there's 4 people here who have Holden, but there's 2 who have a Holden and a Toyota, so it's a total of 6. So 6 over 20 have a Holden. And now we can do the same thing with the complement. We either count the people who do not have a Holden, well, that's those 8 on the outside, and the 6 here in the blue A circle. So 8 and 6 is 14. 14 over 20, there we go. But that's just the same as I've said before, as 1 minus 6 over 20. 1 minus the probability of having B. Now let's investigate the intersection. Well, I've mentioned several times that there's 2 people who have both. So therefore, please be very careful with the notation here. A and B. So that's this little U that looks down like a sad smiley face. That's 2 out of 20. And I want to know how many people have both. So a Toyota or a Holden. Well, that's just the 6 here, and the 2 there, and the 4 there. So that's a total of 12. A or B. That would be the union. Note the little symbol that looks like a U. Now, neither A nor B, that would be those people here on the outside. Those people have not a Toyota and they do not have a Holden. So that's 8. 8 over 20, and the notation here would be not A and not B. Practice this and I want you to do question 1 to 5 of exercise 4b, and the textbook is the Cambridge one, so not the hard copy we're having, and you find all of that on Darnet, and you can come and see me anytime if you've got questions.